Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1, and the question belongs to paper 9709/51 for the session May June 24. Let's see the question number 1. It says a summary of 20 values of x gives sum of x minus 30 equal to 439, sum of x minus 30 whole square is equal to 12405. A summary of another 25 values of x gives sum of x minus 30 is equal to 470 and sum of x minus 30 whole square is equal to 11346. Question number A says find the mean of all 45 values of x. So the question seems to be a little bit exceptional because we might not experience such questions previously. So it's actually, if I say simply, it is a coded data. So this is a coded data. So how to solve the coded data? They have told us to find the mean. First of all, let us find mean. Let me start from the left side of the page. Yes. So on top of the page, we can write that this is a coded data. This is this is a, let me erase this letters. This is a a a coded data. Coded data. Well, okay, so for coded data, we will find the mean. How can we find the mean? They have given, first of all, we'll have to simplify this. The simplification can be done sum of x minus 30. Sum of x minus 30 is equal to, how much is the sum of x minus 30? Is 439, okay? 439. 439. 439. If we expand this, it actually means sum of x minus 30 into number of data. Actually, how many numbers are there? There are 20 numbers, so it is 30 into 20 equal to 439. Ultimately, we are going to get sum of x is equal to 439 plus 600 plus 600. So what will our sum of x be? Sum of x is equal to actually 1039. Similarly, we can simplify the second data. Second data is this one. So let me write just below this. It is going to be sum of sum of, let me write y minus 30 because already we have used x, otherwise it may get confused. Y minus 30 for the second summation is how much? Y minus 30 is given 470. 470, it is 470. That means sum of y minus 30 into, how many numbers are there, how many values are there? Here there are 25 values, so 30 into 25 is equal to 470. Let me write just below this. It is going to be, hence our y, sum of y is going to be 470 plus 750. Hence our sum of y is going to be how much? 407, 1100, so 1220. Now we will have to find the mean. How to find mean? The formula for mean is, so we will find mean. Now mean is equal to mean equal to sum of x plus summation of y over n1 plus n2. So sum of x and sum of y have already been obtained. Sum of x is this. How much is this value of sum of x? Sum of x was this. This is 1039. 1039 plus 39 plus sum of y is, sum of y is 1220. 1220 over n1 plus n2. Number of values in the first case was 20 and in the second case it was 25, so it is 45. Hence our mean is going to be, if I use my calculator, it will show 50.1 something. Okay, if we round it up, then it is going to be 50.2. 50.2. So 50.2 is our mean. I think you have understood how to find the mean from a coded data. Let's move on to the next question. Next question says, find the standard deviation of all 45 values of x. Well, so here we should not forget one concept, that actually coding doesn't affect standard deviation and variance, because remember, if you get confused with these two concepts, then the solution may be wrong. So first of all, we should remember that standard deviation and let it be written standard deviation, and let me change the color of the stylus. Let it be like this. Okay, standard deviation and variance. First of all, it should be written standard deviation, standard deviation and variance, and variance variance are not affected affected by coding. So coding doesn't affect standard deviation and variance. Well, so we will apply the simple concept to find our variance or standard deviation. How can we find our standard deviation and variance? We know, so ST, standard deviation, we can symbolize this by sigma equal to square root over sum of x minus 30 whole square plus sum of y minus 30 whole squared over n1 plus n2 minus 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 sum of x minus 30 plus sum of y minus 30, as we have supposed the second values as y, so it will be y minus 30 over n1 plus n2 whole square. It is going to be whole square, ex whole square means mean whole square. So the simple concept we have applied here. Usually what we do for finding standard deviation or variance is sum of ex squared minus ex whole squared. The simple concept. Then if we substitute the values, sum of x minus 30 whole square is, how much is the value of x minus 30 whole square? X minus 30 whole square is 12,450, and y minus 30 whole square is 11346. So let this information be inserted over here. Is going to be, first one is 12405, 12405 plus, second one was 11346, 11346 over n1 plus n2. Total number of values are 45. Already we have applied multiple times. Minus then sum of x minus 30. Sum of x minus 30 was what? Sum of x minus 30 is 439, and this is 439, and sum of y minus 30 is 470. So 439 and 470, let this be inserted. 439 plus 470 over n1 plus n2 is actually 45, 12, 20 plus 25, so 45, 45, and it will be whole square. Okay, then if we apply our calculator, so calculator will show equal to, it is going to be, hence our sigma is equal to, means standard deviation is equal to, let me use my calculator. It is 1 to square root over 12405 plus 11346 over 45 minus 4 bracket 439 plus 470 over 45 whole squared equal to 10.86 something. So it is going to be, if I round the answer up, it is going to be 10.9. 10.9. So we have got our standard deviation as 10.9 in this answer. So what have we learned from this question? If I show you whole of the solution, it is, in the first case, let me erase this portion. We have learned from this solution that if any data is given as coded data, as coded data like this, so we have, first of all, at the beginning we have written this is a coded data. And how to simplify the coded data? Coded data is written as we have done over here. It is to be simplified. Sum of x minus 30 means sum of x minus 30 into total number of data. Same go, and so was the next one. This one, sum of y minus 30, instead of x, if we repeat x and x, it looks very odd. That's why instead of x I have used y, and y minus, sum of y minus 30 is 470. After that we have found the mean. The formula for mean is simple, sum of x plus sum of y over total number of data, and we have obtained a mean of 50.2. Then standard deviation, they have told us to find standard deviation. Just here we should not forget that for standard deviation and variance don't, standard deviation and variance are not affected by coding. So whether it is coded or non-coded, the formula is same. It is, what is it? Ex square minus ex whole square under square root, means the same formula. What do we apply for standard deviation? It is square root over ex squared minus ex squared minus ex whole squared, ex whole squared, ex whole squared. Well, so this simple formula has been applied for even coded data also. So the main part of our learning from this solution is standard deviation and variance are not affected by coding. We'll apply the simple formula. That's all for the solution to question number A. Let's move on to question number 2. Question number 2 says the lengths of the tails of adult raccoons of certain species are normally distributed with mean 28 centimeter and standard deviation 3.3 centimeter. Question number 8 says find the probability that a randomly chosen adult raccoon of this species has a tail length between 23 centimeter and 35 centimeter. So first of all, they have disclosed that this is a normal distribution. Okay, this is a normal distribution. So let's start the solution. Well, let us write that. Let me start writing from here. So x belongs to normal distribution as they have told, and the parameters for normal distribution are known to us are the mean and standard deviation. So how much is the mean here? Mean is given, the mean is 28 centimeter and standard deviation is 3.3. So let's write the parameters. Mean is 28, 28, whereas our standard deviation is 3.3. Square not standard deviation. Parameters are actually mean and variance. So variance is the square of the standard deviation. Now let us write, they have told us to find the probability that a randomly chosen adult raccoons has species of this species has a still length between 23, look at this, between 23 and 35. So between 23 and 35, how will we write? Probability of 23 until 35. Well, then we will have to standardize the score, all this. It is going to be probability of z less than 23. You know how to standardize the score. Z 23 minus z less than 23 minus our mean is 28, 28 over standard deviation. Standard deviation is 3.3 less than, no, let's not write in this way, as our x is in between them, so z will also lie in between them. Let me erase this. So our z score is going to be probability of 23 minus 28 over standard deviation is 3.3, then less than our z, then 35 minus 28 over standard deviation is 3.3. Well, now if we calculate this, it is going to be, it must be negative. The first one is negative, and 35 minus 3.3, it is going to be negative 1.515. Okay, z negative 1.515 less than z less than, and if we divide 35 minus 27 over 3.3, 7 over 3.3 is 2.121, 2.121. So this is our z score. Now if we look at the normal graph, let me show you the graph. Let me draw the graph over here. So this is the graph. Normal graph is always symmetrical. As this z-score or standard deviation is negative, so it will fall, suppose here, negative 1.5 or something, okay? 1.5, 1.5, and this is 0, mean line, and this is 2.121, 2.121, 2.2121. As this is positive, it must lie on the right side of the mean line. So 2.121 2.1. Okay, now which one is our actually required part of probability? So probabilities, we are to find the probability of actually this portion. Okay, this is from negative 1.5 until 2.2, and you know that the normal distribution is applicable for continuous random variable. How can we find this red zone? Red or red shaded region can be obtained. We will first find the probability when the z-score is 2.1. Then from that, if we subtract just if we subtract this portion, then we will get our probability. So from whole of this, from up from here, if we subtract this green portion, then we will get our red portion. So how to write this? Once again I am repeating. Look, we require the probability of this red shaded region. Okay, then for red shaded region, what we will do, first of all we will find the whole of this until this portion. Okay, this area, this whole of this, when the z score is 2.1. After that, if we subtract this portion, the z less than this portion, then we will get the red shaded region in between them. I think you have got this. So how will we write? We will write probability of when z score, we can write simply equal to, let me change the ink, so equal to probability of z less than 2.121 minus, will subtract just this portion, probability of z less than negative 1.5. Well, so we will write it once again because there is something more to be learned yet. Okay, minus probability of z less than something. Okay, z less than something. Okay, so for no, let me erase this. If there is another concept hidden this, because when the z score is negative, actually no probability is applicable for any negative standard deviation or z score. So what we will do, if I draw the figure once again, suppose this is our normal curve. Okay, normal curve is always, symmetrical, and this one is 0. Okay, now we require this portion. Well, this part here is our z score is what, negative 1.5, and for no negative standard deviation there is any probability given in the probability distribution function. What we can do, as the curve is symmetric, here is also 1.5, z score or standard deviation is 1.5. So from whole of the probability, if we subtract this, look at this, from whole probability, if we subtract this portion, we must get this portion, only this, we require this portion. So this portion is definitely equal to this. Okay, so what will we do? From whole of the probability, we'll just subtract the left onward. So how to write this? We will just write whole probability is actually 1. Okay, from 1 we will subtract probability of z less than 1.5. Once again I'm repeating, why are we undergoing such complex concept? Because for no negative z score there is any probability is given from right side of the main line. That means all the probability given in the probability distribution function are more than zero point 0.5, and the z-score lies on the right side. Okay, that's why it's this is the concept. From whole of the probability we just subtract the unnecessary part. I think you have got this. So let us continue. Now we are going to find the probability of z less than 2.121. I am going to use my probability distribution function, the hard copy. You will be provided such copy in the exam hall. So it is when z score is 2.121. 2.121, it is 0.9830. 0.9830. 0.9830 plus 0. So it is going to be 0.9830, then minus 1 plus, when the z score is 1.51, not 1 point, not 5, it is 1.515. 515, so 51 and 5, 51 and 5. So let me write three decimal places. It is, let me erase this. It is 515. I will have to erase this part also. Well, it is 515. So here also 515. Okay. So when z score is 1.515, our probability is 1.515. Okay, 1.5, 1.9345, and then 6. So 0.9351, 0.93, 0.9351. So after using our calculator, we will get 0.9830 minus 1 plus 0.9351. Our probability is going to be 0.918. Ultimately, this is our probability of this. So what have we learned from this solution? We have learned that in normal distribution, always the first concept was that it is written in between them. In between them, as I have shown here. So we require actually in between 1.5 and 2.1 is actually this red shaded zone. So for red shaded region, what we will do, we will subtract the left part as well as right part. And for these, what we will do, we will find up to whole of this less than 2.1, that is 2.12 is the z score. Then we will subtract when z score is negative 1.515. After that, the second concept is over here. Look, this one should be understood very well, as the normal distribution curve is always symmetrical, and in the normal distribution function there is no probability given for any negative z score. That's why what we always do, from whole probabilities we know that total probability is 1. From total probability we just subtract that z score probability which lies on the left of the z score. So that is what it is, 1 minus p, this portion, this is very important, 1 minus p z less than 1.515. So ultimately we have got this as our answer. Now let's move on to the question number B. Question number B says, before that I should erase this unnecessary part. Question number B says the masses of adult raccoons of this species are normally distributed with mean 8.5 kg and standard deviation sigma kg. 75% of adult raccoons of this species have mass greater than 7.6 kg. Well, so let us write the parameters. X belongs to x belongs to normal distribution, as this is a different distribution. X belongs to normal distribution, and for normal distribution we know the parameters are mean as well as standard deviation. Mean is given 8.5, 8.5, and standard deviation is just sigma, not standard deviation, it's variance. Actually the parameters are mean as well as variance, and variance is the square of standard deviation. And they have told us to find the probability of x is less than, sorry, greater than 7.6 kg, greater than 7.6 kg. So first of all, what we do, we will standardize the score z greater than 7.6 minus our mean is 8.5 over standard deviation is sigma. Well, then if we calculate this, it is going to be 76 minutes, so it must be negative. Actually z is greater than negative zero point 0.9 over sigma. Well, then we will find this. Okay, we have been missing something. Probability is already given, so we will have to write the probability on the right side. How much is the probability given? Probability is 75%, means 0.75, 0.75, 0.75. Sorry, not there, it is to be written over here. Yes, here probability is given 0.75, probability is 0.75, and probability is 0.75. So this is just vice versa to the previous question. Probability is already given, z score is to be obtained. Okay, so let us see the probability. When probability is 0.75, what will be the z score? Or probability, this is no more equal symbol, this will be implies to symbol. Let me write implies to symbol, implies to symbol, and it is going to be, okay, let me zoom it in. Sorry, yes, not so much. Using my probability normal distribution function, we can see that when probability is 0.75, z score is going to be, z is less, greater than negative, 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 negative. Let us see the 0.75. When probability is 0.75, just at the bottom table it is written when probability is 0.75, our z score is 0.674, 0.674, 0.674, 0.674 is equal to 0.75. Okay, there is a possibility of getting confused. You may think that, how can we apply this negative symbol for this probability? As in the previous one, we have come to know that no probability is given for negative standard deviation or negative z score. Here, if I draw the figure, it's actually, it will look like this. Okay, so here where is it is 0, our negative z score is, it is 0.674. Okay, or it is zero point 0.9 over, suppose this one. Let me draw more precisely. Suppose this one. Okay, so this one is, our z score lies over here. Okay, this portion is zero point 0.9, zero point 0.9 over standard deviation. So this is our z score. Okay, this is our z score. Well, now it is negative definitely, as it is lying on the mean line. So they have told greater than, we should not forget that this is greater than symbol. Here look at this, the symbol is greater than, that means right side. Greater than means this portion is our probability, which is 0.75. Now we will find that as the normal graph is always symmetrical, so here there is, you know, this portion, here also the standard deviation will be zero point 0.9 over sigma. So which portion do we need? We need now this portion. Okay, this portion was 7, this is 0.75. The this region is, the probability of this region is 0.75. So for 0.75, what will it be? Actually it causes no change. If we suppose, look at this, from whole of this probability, if we subtract we require the left side. Okay, now this portion, for this portion from 1, if we subtract this portion, okay, if we subtract this portion, then again it is 0.75. So it's all the same actually, for if the probability is already given, so we can apply the same concept. Both of them are negative in this case. Well, so let me erase the graph, or I can write just below this, or beside this, no, not beside, above this, as I don't have space to write below this. I can write above this. No, writing above is not good, so let me erase this. Hence we can write both of them are, this portion is z greater than this portion is also z greater than, so they must be equivalent, and symbol is also negative. I mean same in both cases, so it is going to be zero point 0.9 over sigma is equal to 0.674. That means our sigma is going to be 0.9 over 0.674. Well, hence our standard deviation is going to be, if we divide zero point 0.9 over 0.674, that means 1.33 something. Okay, let it be rounded up, it is going to be 1.34 is our standard deviation. So don't get confused in this case. In the previous one I told that for no negative standard deviation there is any probability given, but as here probability is already given, we have just found the z score. So when probability is given, z score, it already we have decided it is negative, but as the curve is symmetrical like this, let me draw over here, this curve is symmetrical, this is the curve, so it is symmetrical. Whether, okay, we will have to draw actually two curves, not this one, for better clarification. So one curve is this, okay, this one, and another one is with, so this one, where our z square is what, negative, just over here, negative zero point 0.9 over zero point 0.9 over how much, sigma. Okay, this is 0, the central line. Then for the second one, so where is, which one is our probability here? It is z greater than, look at this, the symbol is greater than, that means this portion is our probability, which is 0.75, 0.75, 0.75. And if I draw another curve, same curve, so here our probability is what, our z score is point, here it is 0, so 0.674 or zero point 0.9. Okay, for 0.9 over sigma. Now look at this, they have told our probability is 0.75. So which portion is 0.75? This portion, this is our probability. Okay, so this is our probability, which is 0.75. Okay, so it's all the same actually. Once our score was here, z score was this, and second time our sorry, different ink. So this is our z score, first case. In the second case, z score is this. So it's all the same actually. Our probability is getting unchanged because this one is 0.75. Here also probability is 0.75. As the probability is same, so z score will also be same, isn't it? Just the difference is positive and negative symbol. Here it lies on the left side, that's why it is negative, left side to the mean line. But in the second case, the z score lies on the right side of the midline or mean line, but probability is same. As the probability is same, so z score will also be same, this z score and this score. But original z score is actually lying on the left side, that's why it is negative in both cases. So leaving our probability same, we can fix our z score. Z score may be positive or negative, but for probability, probability will remain same. Probability here in the first case 0.75, in the second case also probability is 75. Once it was on the right side, on the other, on the other hand, or in the other case, the probability is lying on the left side. So z score is actually same because it is mean line and the graph is symmetrical. Well, I think you have understood, and we will clarify more confusions in the next solution, inshallah. So Allah Hafiz. um, Thank you all for watching the video.